Thank you all for joining us for the Q&A with the inventor of Python. Before we start, I have a few quick things to go over. If you haven't yet, please check in at aka.ms/reactor-checkin using event ID 13426. You can use the live chat to ask questions, and we will try to answer as many as we can. We will also be sharing some links to the Reactor Meetup page and monthly newsletter if you are interested in checking out what other sessions we have coming up. And finally, today's session is being recorded and will be added to the Reactor YouTube channel. I am now going to pass it over to Francesca.
Thank you, Dion. Hi, everyone. So today, it's really my pleasure to have this conversation with Guido. Guido van Rossum is the creator of the Python programming language, and he grew up in the Netherlands and studied at the University of Amsterdam, where he graduated with a master's degree in mathematics and computer science. And then after college, he created Python, and today we're going to talk a lot about it. He then moved to the United States. I know that in 2005 he joined Google, in 2013 he joined Dropbox, and finally now is a distinguished engineer at Microsoft. So welcome, Guido, and thanks for joining us today.
Happy to be here. Nice to meet you, Francesca.
So let's start with the first question. It is more like a general question. So can you share a little bit more about the story behind Python's start? So why and how did you decide to develop it as a side project?
Well, how much time have you got? That's that. I have a
Unfortunately,
long
only
version of
45.
that story. I'll try to cut it down a bit.
Yeah.
So after college, I joined a research lab in the Netherlands called CWI. And my first project there that I worked on for 3.5 years was the implementation of a programming language. The language was named ABC. It was a beautiful design. I really enjoyed working with that team. I learned a lot. And the language totally flopped. It was impossible to find users. We didn't have any distribution channels. We didn't have any obvious ways to promote our language. And so the project was canceled. I worked on other things, including a distributed operating system named Amoeba. But at some point, I think during the development of Amoeba, I was writing a lot of application code because Amoeba was sort of this super researchy thing. There was a microkernel written by a couple of PhD students. And I was actually hired as a programmer, and our task was to sort of fill out the operating system with useful applications. Like there was a shell, there was a compiler, but there were no like backup tools or mail readers or any of those handy things.
Mm-hmm.
So I was writing utilities, and since the only compiler we had was a C compiler, my choice for every utility was write it from scratch in C or cobble it together as a shell script. And often the sort of the purpose of the tool was such that it wasn't so easy to write it as a shell script, so I was writing stuff in C, but of course productivity in C is very slow. And I sort of, at the same time, I had in the back of my mind, this ABC language was such a wonderful thing. It's a shame that I couldn't write my utilities for Amoeba in ABC. And I thought, well, okay, and now we get to the point where it was good that the project leader was on a sabbatical in Silicon Valley and left the team of programmers more or less to themselves. And I had no social life. So I decided over the Christmas holidays, actually, that it would probably take me about 3 months to design and implement a new programming language based on many of the ideas from ABC, but also ideas I had myself, and I had sort of some criticism on parts of ABC. And then after those 3 months, I would be much more productive, and everyone else on the team would also be much more productive in our creation of utilities for Amoeba. And then within half a year or so, we would be even. And after that, it was pure sort of an increase in total output of the team. I did actually, after 3 months, have a sort of a demoable version of Python.
Wow, okay.
But basically, Python continued to consume my life for much longer than I had anticipated. I mean, I think the story about productivity was more or less an excuse to do something I thought was more fun than writing utilities and cranking out backup tools and that kind of stuff. So I think in the end, for the Amoeba project, we probably sort of was maybe a break even. But for myself, it was obviously a big success. After a little more than a year, several people who also really enjoyed using Python, because we were using it. We even had, like, the first summer we had an intern using Python for some crazy stuff. So it was a useful tool. We decided to open source it, which at the time was a very different process. But this time, I hooked into something called Usenet, which was an online community mostly focused on the US, but sort of with branches in Europe and other parts of the world. And sort of, we promoted Python there,
Mhm.
and it was an instant success. My inbox started filling up with sort of fan mail and bug reports and unsolicited sort of feature requests and patches and all sorts of all the good stuff that you sort of you want, that strokes your ego and that helps
Mhm.
sort of that make the thing a better thing.
Well, that is a fantastic story, and I think that we are all very glad to hear that you decided to develop this programming language. And something that I'm curious to hear more about, and we received this question also on Twitter. I work in the machine learning and AI space right now. So did you predict Python being used so much in the machine learning and AI community when you started the language?
Oh my gosh, no, not at all. I had no idea. I mean, this was like 1990. I think it was still the sort of the deep AI winter. AI was a very sort of disrespected field because in the 60s and 70s it had made so many promises and none of those had really come true. And so everybody thought that was a dead field, that we wouldn't get to any of that science fiction for another century or so. Well, clearly there were people who had other ideas, but that was sort of the general feeling. And sort of the goal of Python really was to be another tool in the toolbox of professional programmers, serious software developers who would otherwise be writing code in C or C++ maybe, or as shell scripts.
Yes, and right now there are so many different frameworks that are used for deep learning and machine learning. So it's very interesting to see how the evolution of Python has actually impacted the machine learning and AI field so much. So I got another question from one of the guests that says, so I read your blog post about the origins of the functional features of Python. What can you say as an update now in 2021?
Yeah, so I shouldn't repeat what I wrote in that blog post. Actually, it's a pretty old blog post. I don't even remember exactly what I wrote at the time, but I imagine that it described how a sort of fully featured implementation of Lambda, Map, Filter, and Reduce appeared in my inbox I think in the early 90s actually. It might have been the mid 90s. And I didn't know much about functional programming. I had heard some talks from some academics about certain functional programming languages, and I thought it was marvelous, but I didn't really understand it, and I had never tried to use a functional language myself. But at that time, I was basically taking every new feature that sort of that felt okay to me. I would just sort of scratch my head for a few seconds and say, sure, let's put that in the language and release a new version. And now we have these things. I think lambdas have been very successful despite them being intentionally sort of simplified. They've also been widely misunderstood. People have often, I remember almost getting into a shouting match with someone who thought that only lambdas had the semantics of closures and nested functions did not. And there was like a huge misunderstanding based on that. I think we both had a little too much beer, so it was fine in the end. So filter and map are pretty useful things, but I've never been able to sort of follow code that was using reduce, whether in Python or in other languages. So eventually I decided to sort of cut it out of the built-ins. And there's still people on Hacker News who are mad at me for that, but it's my language, not theirs. You can design your own language, and they've done for sure. But what happened instead was that a guy named Tim Peters, I think, whispered in my ears something about comprehensions. Now that was something that I was familiar with because, like, in college in your first math class, they show, or maybe even in high school, they show you this set notation where you say all the x vertical bar where x is greater than 5 or something. And that made total sense to me. And so the specific notation of comprehensions, which started out with list comprehensions and generator expressions, and eventually was expanded with set comprehensions and dictionary comprehensions. Thanks, Barry, for those. That's been like a real game changer for the language, I would say.
Very, very interesting. And here I got a different question, but still very interesting. That is a more general question about the scope of Python in web development and mobile app development. What's your take on this?
Oh, those are two very different questions.
Yeah.
And take web development. Of course, web development neatly separates in a front end and a back end, except then that the people who write the back end code have a whole stack of layers where there's still a front and a back. But if you have sort of the stuff that runs on the browser versus the stuff that runs on the server, all the stuff that runs on the server, Python is a pretty popular language there. At Google, I worked on projects that were sort of built on Python, although most Google stuff wasn't. At Dropbox, the whole Dropbox server is built in Python. On the other hand, if you look at what runs in the browser, that's the world of JavaScript. And unless it translates to JavaScript, you can't run it. And there have been various experiments. I mean, I remember there was a time that people wrote applets. And there was actually, even in 95 or 96, I believe, there was some crazy hack where web browsers, I mean, I think there was only one web browser and it could dynamically load an extension and then you could use an arbitrary language. But it was very limited. I think the other language then would have like a square box on the screen of fixed size where it could draw what it wanted, and that was about it. But we got that working for Python at some point, but it wasn't successful because users would have to download that extension and install it in their browser. And there were 1,000 things that could go wrong. Plus, most users weren't so keen on downloading and installing stuff before they could sort of run a website that they were planning to visit for about 5 seconds.
I see.
Java actually tried to do the same thing and similarly failed. So I'm not particularly worried that didn't work. Now, of course, there are various people who have different strategies for running Python in the browser. There are a few projects. The only name that I can remember is Brython, but I think there are a few others that somehow translate Python to JavaScript or have a Python interpreter written in JavaScript. In theory, you put that on your website and your users will never have to know. And some people do that. Especially the translation approach can be pretty effective, but it's like you have no support from the browser vendors. Nobody in the Python community knows what you're doing. It's very limited because the environment in the browser has sort of very different I/O primitives. You can't block for I/O, for example. You can't open a file and read a bunch of stuff from it, really. So that is still not very popular. There's also WebAssembly. People have done sort of hero projects where they translate all of CPython into WebAssembly because there are experimental GCC backends that just produce WebAssembly code instead of machine language. And then sort of to make it useful, they compile all of the scientific data stack, and you can sort of do numeric data processing, and it all works, and WebAssembly is amazing. But in the end, it's a big download, and you have something that comes short of the performance and the functionality of when you just ran the whole thing in a notebook on your own computer, or ran the whole thing on a server with the proper UI. So I don't know if there's a future for that. I don't mind so much. Different languages have different goals. I mean, nobody's asking Rust when you can write Rust in the browser. At least that wouldn't seem a useful sort of target for Rust either.
Yeah.
I mean, Java failed in that respect, and that they don't have any problem. I mean, Python should focus on the targets, the sort of the application areas where it's good. And for the web, that's the backend, and for scientific data processing, that's pretty much everything, as long as you can wrap something like TensorFlow or PyTorch or NumPy-based things in general. So coming back to mobile app development, that is a little bit of a sore point. It would be nice if mobile apps could be written in Python. There are actually a few people working on that. But CPython has 30 years of history where it's been built for an environment that is a workstation, a desktop, or a server. And sort of it expects that kind of environment, and the users also expect that kind of environment. So if the people who sort of have managed to cross-compile CPython to run on, say, on an Android tablet or even on iOS, they find that it eats up a lot of resources. Now, if you're in a classroom situation and you plug in your tablet and you connect a keyboard to it and you want to learn to code, well, maybe you have a slightly cheaper setup than if you use the Chromebook or something like that. So especially in third world countries, tablets or even phones are often the only thing that people have. But running CPython in that environment is it's not a great fit because it's still compared to what the mobile operating systems expect. Python is big and slow.
Mm-hmm. Yeah.
And it basically uses a lot of battery charge. So you can if you're coding in Python, you probably very quickly run down your battery. You also probably quickly run out of memory. And like Android that pretends to be a Linux system, but you can't actually fork a process. So that's a problem because now Python code that important Python libraries like multiprocessing detect that they're on Linux and they know to create a new process, you fork. Well, that doesn't work. So now does multiprocessing have to figure out how to create another process on an Android
Yeah.
device? So it's like it would be nice if there was more, but it's not an easy thing to introduce. And I wonder if for mobile development it wouldn't be better to start with something like MicroPython, or maybe a medium Python, which assumes there is an operating system and a fair amount of memory, but doesn't assume it's running in an environment like CPython.
Mm-hmm. And you mentioned some of the newer programming languages, such as Rust, and that, of course, is aiming at different audiences and at solving different type of problems. There is also another language like TypeScript. What do you think of those languages?
Oh, I love languages, at least in theory. I mean, I always read language tutorials. I'm very bad at actually downloading a language implementation and trying to code something, because it's almost always easier to, I already know how to do that in Python, and or I just want to contribute to Python. So I haven't actually learned Rust. I've spoken to many people who have and who have written serious applications in it or are writing serious applications in it. And it sounds like it's a great language for certain things. I mean, Rust really improves on C++ in one particular area. It makes it much harder to bypass the checks in the compiler. And it's, of course, it solves the memory allocation problem in a near perfect way. I'm sure that if you're developing a really large, serious application, every once in a while you end up having to cheat, and then you're still on your own. But it's much harder to be sure that. So if you wrote the same thing in C++, you could not be as sure that as compared to Rust, that like you've gotten all your memory allocation and memory management stuff right. So Rust is an interesting language. I still think that Go is a very interesting language too.
Okay.
Of all the new languages, Go is probably the most Pythonic, or at least the general purpose new languages. There's also Julia, which is an interesting take on something Python-like. it has enough details that look very similar to Python that then when you realize, oh, but all the indexing is one-based and ranges are inclusive instead of exclusive, you think, nobody should ever try to code in Julia and in Python on the same day. My understanding is that Julia is sort of much more of a niche language, and if you're in that niche, it is superior because the compiler sort of optimizes your code for you in a way that Python probably never will. On the other hand, it is much more limited in other areas, and I wouldn't expect that anybody ever is going to write a web server in Julia and get a lot of mileage out of it. And I'm sure in 5 minutes that will be on Hacker News with a counter example. Sorry, you mentioned TypeScript, also
TypeScript.
a great language.
Yeah.
You might have noticed that in the past 6 or 7 years, we've been adding optional static typing, as we call it, to Python,
Yep.
also known as gradual typing. I wasn't actually aware of TypeScript when we started that project, so I can't say that we were sort of inspired by TypeScript initially. TypeScript, because it sort of jumped on the JavaScript bandwagon, I think did a few and because Anders is a really smart guy, TypeScript did a few things that Python is still sort of waiting to figure out. So nowadays we definitely look at TypeScript for examples and sort of we have a typing sig where we discuss extensions of the typing syntax and semantic and the type system in general for Python. And we definitely sometimes sort of propose new features because we know that certain features were also sort of originally excuse me, initially lacking in TypeScript and then added to TypeScript based on user demand and very successful in TypeScript. And so now we can see we are in that same situation because JavaScript and Python are relatively simple. So TypeScript and Python type system are also relatively similar, much more so than Python and say C++ or Rust or Java. So we are learning from TypeScript, and occasionally from my conversations with Anders, it sounds like TypeScript is also learning from Python, just like JavaScript has learned from Python in a few areas.
So you mentioned C++, and we do have a question from a professor who is asking if you think that universities should teach Python before teaching other programming languages such as C++, for example. I also know that
absolutely. Yeah.
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 There's
no doubt about that. There. A few years ago, there was an interesting article published in the Communications of the ACM about sort of surveys of major universities that had all switched to Python as their sort of intro to coding classes. Even MIT's famous whatever. Well, MIT had a scheme-based class for decades, and they're still teaching that, but the vast majority of students first learn Python with a robotics class.
Yeah. And so going back to Python, like more like the evolution of Python, one of the questions that I wanted to ask you is like if you have to share with us one biggest learning, from the transition from Python 2 to Python 3, what is that?
The biggest learning. So I normally talk about that as sort of a mistake because Python was more successful than the core developers realized.
Hmm.
And so what we should have been much more aware of and much more sort of supportive of transitioning from Python 2 to Python 3. And in our own experience, we thought that that transition would be relatively simple because we were all like the Einsteins of Python programming, of course. And we could translate code from Python 2 to Python 3 in our sleep. And probably our Python 2 code already was written in a style that didn't need much translation anyway. What we found was that Python actually is also very successful with people who aren't great programmers. And there are whole sort of groups of businesses that write Python code that solves some problem for another business and is delivered as an application that then sort of runs without supervision. And these are custom projects. And so all these things are left running on servers. It's like old Excel spreadsheets almost that sort of survive any reorg in the organization, that software is still running. But it doesn't survive an upgrade from the default Python binary to something newer. And we totally neglected that was happening to Python. We basically thought, oh, there are a few other smart people like us who are loving Python, and they would all agree that Python 3 is better than Python 2. And it turned out that the situation was much more nuanced. So certainly, if there ever is going to be a Python 4, well, if you've seen my Twitter stream, if you look me up on Twitter, I pin a tweet that is like a 2-line FAQ about Python 4, which is basically the transition to Python 4 will not be anything like the transition to Python 3 was, because we've learned our lesson.
Interesting. And how about dependencies resolutions? Like I know that pip now is pip 21, right? Has a very good support, a very good offer in terms of dependencies resolution. So, is there going to be something new there on that aspect in the next version of Python?
I still think of that as something that really is outside the language proper. Pip is not the only package manager.
Mm-hmm.
Even pip 21 is not perfect in its sort of dependency resolution. It's always better to use virtual environments and sort of have a separate virtual environment for each application, because that makes it much easier to avoid what used to be called DLL hell, because that's or version hell.
Mm-hmm.
But it's not, you can't avoid versioning hell in all cases, unfortunately, and that's unfortunately a fact of life when you're developing software that is built on top of layers and layers and layers of other software, as especially the people in machine learning and data science world, of course, are doing all the time. There's so many useful packages, but different communities developing different sort of packages don't always have the same policies about sort of which versions of lower level packages they support. And then when someone in an application tries to sort of combine pandas and PyTorch and TensorFlow, you probably get into terrible trouble.
I see. So we will see in terms of the next version of Python. There is someone here that is new to Python, is a guest, and he's asking is curious why it is called actually Python.
Yeah, I forget to mention that detail in the origin story. So, one, I'm a big fan of Monty Python's Flying Circus, always have been. Uh, that show sort of made a few appearances on Dutch TV I think in the early 70s, and I just was floored. I thought it was so funny. I learned English from that in part. So anyway, it's named after Monty Python's Flying Circus, and for the longest time, I resisted any sort of use of snakes for Python logos. I remember designing a logo for Python for the very early Mac version. This was like Mac OS 8 or so. Very, very cute hardware. And the logo I designed was a 16-ton weight, because that was a sort of that was the simplest thing that I could draw with sort of my limited drawing skills, and it had to fit in 16 by 16 pixels. Sorry, it was a two-part question, and I blanked out on the second part.
This person was no, there was just saying that he's new to Python, and so he wanted just to know a little bit more about the story of the name Python, and I think that you answered that.
Okay, yeah. The other part of the story was that in Amoeba we had sort of a local tradition, which was just sort of a joke among the 3 or 4 programmers working on it, that we named various parts of the system after popular TV shows. And the third part was that I recognized that there was a trend in naming languages after sort of important historical figures from the world of science and math and engineering, like Pascal or Ada or Eiffel. And I was in a rebellious mood, and I thought, I don't want it to sort of be named after a Greek god or an important figure from the Renaissance, and I didn't know those names that well either, although I had learned a few of them in school. And so sort of choosing references to pop culture was my way of sort of going against that.
That's a nice story. There is another guest that is also asking a very interesting question about Python for quantum computing. So he's asking you, there will be Python for quantum computing, or do you think that is too soon to know it?
I think even MicroPython requires more memory than a quantum computer has. So
Great.
I don't know what to do with Python in quantum computing. I know that there is a Microsoft package that I think claims to emulate a quantum computer, and it's all written in Python. But that's not really, to me, that's not really an application of Python in quantum computing.
And speaking of Microsoft, so right now you are a distinguished engineer at Microsoft. I know that you work in the developer division. So that division is also well known for tools such as Visual Studio Code, that is supported by the open source also community. And so what's your role there? And do you have a specific plan?
So I came out of retirement mostly out of boredom. A year and a half ago, I left Dropbox, and I was really done there after 7 years. And I thought, I'll go travel with my wife, and we'll go on lots of bike trips, and we'll get together with friends. And then the pandemic happened, and life was pretty limited. And I realized I needed a project, and I started going back to coding and sort of specific Python improvements. And I I have to admit, I got frustrated with a certain thing I wanted to add to Python where there was just endless discussion that kept going around in circles. And I thought, maybe I should just get a job again. And I asked around and I found that I could actually work at Microsoft part-time. And I don't know, I still think that a mistake was made somewhere and they accidentally set me up with interviews with people at the sort of VP level. I remember being interviewed by Kevin Scott, who of course is the CTO, but at the time that I had blanked out on that. So in the middle of the interview, we were getting along great, and we were just chatting about random stuff. And I asked, "Yeah, so what exactly is your role in this company?" So I'm actually very surprised that they still decided to hire me. And I'm an individual contributor. I I'm not a director, and I sort of for 3 or 4 months I actually just oriented myself in the company, uh, taking meetings with random people almost in the meeting who are doing interesting stuff with Python in the context of machine learning, of course, Azure, notebooks, Excel, you name it.
Mhm.
Uh, and at sort of nobody told me, well, shouldn't you be sort of getting your hands dirty with coding? But I felt that I went back to the workforce so that I could do more coding on a focused project and not so that I could take meetings all day long, 3 days a week. And so I sort of started a systematic search for, well, what kind of project shall I take? Because I was pretty much given complete freedom in what I would wanted to work on.
Mhm.
And so I looked into machine learning and notebooks, and I realized that machine learning uh, is a very big field, uh, which I
Right.
have despite Python's big success in that field. And I would say that the field has become more successful because of Python, and Python has become more popular because that field has taken off. That's very nice symbiosis, but I've always sort of ignored that field. I know exactly how to build a web server in Python or a web client or something doing something with databases or user interfaces. I have no idea how to begin writing a framework for machine learning or even how to do a simple machine learning application. I've tried to follow tutorials in that area, and I've talked to various people. And of course, I had like super good access to all sorts of smart people in the machine learning field at Microsoft as well. And I realized it would be a mistake to try and sort of contribute to that field because it takes like you got to spend 3 or 4 years on a PhD in the field, and then maybe you can contribute something useful. I don't know if that's your experience, but that's sort of what it felt like to me. And so in the end, I decided I would go back to my roots, uh, and sort of collect a team of people and start working on making Python faster. And at the Python Language Summit earlier this week, I actually announced this sort of publicly, uh, that now together with two other core developers, Eric Snow and Mark Shannon, and
Mhm.
Mark especially is a longtime expert on faster Python virtual machines. So I'm very excited that we're going to contribute as core developers and as Microsoft employees or contractors uh, directly to CPython. We've contributed a few small things to Python 3.10, but 3.10 just went into beta a few weeks before we sort of launched our initiative officially. So now we feel we have about a year to prove that we can actually move the needle on Python performance, and 3.11 will be much faster than 3.10. And it's interesting, the sort of making Python faster has also attracted the attention of groups elsewhere. There is a team at Facebook who just open sourced their efforts, mostly focused on Python 3.8.
Okay.
There are a few ex-Dropbox people who work on a thing called Piston. They had Piston version 1 was a Dropbox product that was open sourced. Piston version 2 was just open sourced. It's based on Python 3.8 again. I know there are a few people in other places that haven't come out and said so publicly. Oh yeah, there's also Anthony Shaw, who is a developer advocate at Microsoft, who in his spare time, I think, after completing a book on CPython internals, which I can recommend to anyone who wants to get going with hacking on CPython, he decided to teach himself more about virtual machines and just-in-time compilers, and he picked up a project named Pyjion. I think it's spelled Pyjion, which is a JIT compiler for Python based on the .NET framework. So making CPython faster or making Python faster is sort of suddenly back on the front page of the news, I would say, and I hope that with my team I'll be able to contribute some to that field, which feels like I do know something about that area.
Yes, and we are so glad to hear that. It sounds very, very exciting as a plan to have at Microsoft. And also I really like, the fact that there is interest from other teams at other companies in the community. So that's great to hear.
Mm-hmm.
So there are a lot of people that are actually asking the same question, that is there going to be a Python 4? I think that probably the most interesting question is there's going to be like the next version of Python. I'm not sure if it's going to be Python 4. And if you want just to share a little bit more about what are going to be like the most important changes, if there are going to be any important changes.
Okay, well, so Python 4, at this point, whenever Python 4 is mentioned in the core development team, it is very much as a joke. We've learned our lesson from Python 3 versus 2, and so it's almost taboo to talk about a Python 4 in a serious sense. And most of the time, when people say, "Oh, we'll do that in Python 4," everyone is in on the joke, and it's just a funny way of saying that will never happen. I'm sorry. So Python has point releases, and so we've currently the most current version is Python 3.9. The version that just went into beta, we've had like alpha since the beginning of the year, and the sort of final release date is going to be October, will be 3.10. And we now have a strict annual release schedule. So a year after that will be 3.11, and after that will be 3.12, and so on and so forth. And we can go up to 3.99 before we have to add another digit.
Yeah.
But going from 1 digit to 2 digits was definitely not completely trivial, but still much better than going from 3 to 4. So will there ever be a Python 4? And how will it be different? I don't know. The sort of the speeding up for Python is just going to be incremental, and it will not be. I mean, it will just like some new speed will be coming in 3.11, and then we'll speed it up more in 3.12, and then we'll speed it up more in 3.13, and so on. I could imagine that at some point we are forced to abandon certain binary or API compatibility for C extensions.
Okay.
We might want to change the way garbage collection is handled. Currently, it's done through reference counting. The reference counting machinery is pretty sort of public and directly accessible by third-party extensions, which makes it very hard to change any aspect almost of the memory management. The global interpreter lock is also something that people have been hoping to get rid of for a very long time. The last attempt was by Larry Hastings, the Galectomy. I think he's given up on that. I haven't heard a status update in a long time, and Larry seems to have moved on to other hobbies. Still in the Python world, of course. But if there was a significant incompatibility for C extensions without changing the language itself, and if we were to be able to get rid of the GIL, if one or both of those events were to happen, we probably would be forced to call it 4.0 because of the compatibility issues at the sort of the C extension level.
I see. Yeah.
I think the current plan for getting rid of the GIL is actually very different. We're also, and my colleague Eric Snow is also working on that. There is a project called Multiple Subinterpreters, which is a feature that we've sort of had for a long time, but it had various issues. And slowly we seem to be migrating to a version of multiple subinterpreters where there's no shared data between the subinterpreters at all, except that they all live in the same process. And you can switch between them very efficiently. And at that point, once each subinterpreter has its own global interpreter lock, we will have a different approach to sort of using all the cores that you need, because you can just spin off worker threads in a sense, except worker subinterpreters.
I see.
And that's probably a more effective model than sort of multiple threads with shared everything like we have in Java or C++. So that approach to getting rid of the GIL would not require renumbering the version of the language. So then the only thing that really would require us to sort of declare a sort of major incompatibility event would be other changes in the C API. And I personally think that we can actually just gradually make those changes over time, deprecate things slowly, offer a much more gradual upgrade path to important third-party extensions like NumPy and PyTorch and TensorFlow and Panda. Yeah. So again, I'm not thrilled about the idea of Python 4, and nobody in the core dev team really is. So probably there never will be a 4.0, and we'll just keep numbering until 3.33, at least.
Yeah, and that makes totally sense to me. Okay, so I know that we are about at time, so I would love to conclude this wonderful conversation actually with a question that is a little bit different, that is about your hobbies. Like beside Python, do you have any other hobbies that people can know a little bit more?
The human interest question. Yeah, well, it's sort of, I like reading. I mean, I'm a very boring person. I like my family. When our son was born 19 years ago, I posted a birth announcement on the Python mailing list. I wouldn't do that anymore. Uh, we're more private now. Uh, I do like reading science fiction and fantasy. I like watching shows in that area, especially with our teenager who is now 19 and wants to be a. Okay, I can admit that Orlane wants to be a bass player in a metal band. So that's like the career choice that is sort of most different from what his parents are doing, which is very typical, and I fully support him in that. But more about myself, I like to hike. I like to go on bike rides. Nothing very strenuous. I have a friend who occasionally rides his bike across the United States. I could never do a
Oh,
thing like that. That's like
that's impressive.
amazing. Yeah, yeah. Uh, I go for a 2 hour bike ride, and my spirits have been lifted, and then I lift my bike onto the bike rack on the back of the car, and we drive home. That's how I like to do it.
That sounds very, very
Yeah.
nice, especially with the good weather that you have in California.
Oh yeah,
It's fantastic.
we love it here. We're really very happy.
Perfect. So unfortunately, we are at time, and I personally really, really enjoyed this conversation. I learned a lot more about Python and yourself. So thank you so much again for joining us.
Thank
And
you. You've been a very good interviewer.
that I'm glad to hear
Yeah.
that. And also I want to thank the rest of the guests. Thank you all for coming, and thank you, Guido. Again, it would be very nice to keep in touch and learn more about your Python projects at Microsoft.
Of course.
Bye, bye everyone. Thank you again.
Bye everyone.